Hello out there, you are welcome to Davetuts Academy, where we are devoted to academic excellence in students, especially for the STEM subjects. Today, as a guide to preparation for our exams, we are going to be looking at the detailed solution to the past question from WAEC Mathematics 2018 November-December theory paper, and that is paper 2. And now, if you are out there and you are preparing for some exams, say you are preparing for your GED, your GCSE, IGCSE, your NECO exam, this video is also going to prove quite useful because all of these exams, they share the common topics in their mathematics, and with that, we can move ahead to go and look at our questions so that we can prepare best for our exams and gain academic excellence in our endeavors. Now, in addition to this video, there is a workbook that is provided free of charge for download that you can also work along. Is to go ahead, check on the link in the description below, download the workbook, make it a point of duty for you yourself to also train yourself, get hands-on in preparation for your exams. For example, first you can look at the question, you can attempt them, then by the time you are through, you can check back with the solution that was featured in the PDF book. And if you are still having some gray areas, then you can go ahead and watch the video so that you can brush up on your exams. So with this, what we are aiming for is that you will be the best in your academic exploits, and academic excellence will be your portion. So with that, let's head over to our video and do our workings together. In this question number 1, we are given that the sum of the first 10 terms of an AP is 130. The fifth terms is 3 multiplied by the first term. So we have to find the common difference, the first term, and the number of terms of the AP if the last term is 28. There is a general formula for the sum of the first n terms, and there is a general formula for the nth term, which is as written in the board. And here, in the definition of the equations, A is the first term, and D is the common difference. So, interpreting the question we're given and plugging in the values will help us to solve this. In the first case, we are told that the sum of the first 10 terms, S10 is 130. So we have S10 is 130, and using the first equation for Sn, that will be 10 over 2 into 2a plus n minus 1 will now be 10 minus 1 multiplied by d. So if you cut, we are going to have 2 times 13 on the left hand side. That's 26 is equal to 2a plus 10 minus 1 is 9. So we have plus 9d. We can call this equation 1 and then move on with our question, in which we are told that the fifth term, T5, is 3 times the first term. So normally, first term is A, so fifth term that is being evaluated as 3 times the first term will be 3a. 3a is equal to, now the formula for the nth term, A plus, now n is 1, n is 5, A plus 5 minus 1d. So with this, we can collect like times. 3a minus a will be 5 minus 1 is 4d. So that will give us 2 is equal to 4d. And if you divide all through by 2, we are going to have here a is equal to 2d. Now, this we can express as equation 2. And we have a set of simultaneous equations that we can solve with whatever method is suitable for us. And looking at this, substitution is looking quite good. So we can say, using equal 2 in equation 1, that will give us 26 is equal to 2a, but instead of a, we now use 2d plus 9d. That will give us 26 is 2 times 2d is 4d plus 9d. Then we know that is 13d, and d will be 26 over 13, which is equal to 2. So now, our a was expressed as 2d, so that will be 2 times 2, which is equal to 4. And with this, we have gotten the common difference and the first term in the question that we are asked. And then we want to find the number of terms n if the last term is 28. So Tn was given as 28, but we know the general formula is a plus n minus 1d. But instead of a and d, we can put in the values we got. That will be 4 plus n minus 1, the d is 2. Okay, so with this, we can collect like terms and open our bracket. That will be 28 minus 4 is equal to 2n minus 2. So 28 minus 4 is 24, and 24 is 2n minus 2, meaning that 2n is 24 plus 2. When minus 2 moves to the other side, that will be 26, such that n will be 26 over 2, and that is equal to 13. So that is the number of terms if the last term is 28. Now, question number 2a. In a right angle triangle, sin x is 3 over 5, and we have to find 5 cos x squared minus 3. Now, when we are given sin x is equal to 3 over 5, we know sin x is opposite over hypotenuse, that's sine. So meaning that our opposite is 3 and our hypotenuse is 5. So if we are to draw our triangle out, and we are to take this as x, then opposite is 3 and hypotenuse is 5. We are looking for the adjacent because we will need that in the cosine of x. And by Pythagoras theorem, 5 square, which is the hypotenuse square, will be opposite square plus adjacent square. Now, hypotenuse is 5, opposite is 3, adjacent is what we are looking for. So, if we solve this, we will have that a square is equal to 25 minus 9, which is 16, such that a is square root of 16, and that is 4, and meaning that we have gotten the value of all our sides. Then we can say we want to evaluate 5 cos s squared minus 3. Now, to get 5 cos x squared minus 3, we need to know that cos x is adjacent over hypotenuse, and we have gotten our adjacent. So our cos x will be a over 5, and a was gotten to be 4. So cos x is 4 over 5. So with this, 5 cos x squared minus 3 will be given as 5 multiplied by 4 over 5 all square minus 3. Now, that will be 5 into 4 square is 16, 5 square is 25 minus 3. And 5 can go in 25 to give 5. So we add is 16 over 5 minus 3 over 1. We find the LCM, 5, that will be 16 minus 5 times 3 is 15, and that will amount to 1 over 5. So the value of what we are asked to find is 1 over 5. Now, question number 2b. The base of a pyramid, 12 cm high, is a rectangle with dimensions 42 cm by 11 cm. It's filled with water and emptied into a conical container of equal height and volume. We have to find the base radius of the container. Now, without understanding what a pyramid is and what a cone is, they will not be able to solve this question. So, first and foremost, let's get the diagram of a pyramid and the diagram of a cone. Now, we're told that the height of the pyramid is 12 centimeters. So if you are drawing our pyramid, this is our pyramid, and the height is 12 centimeters. So we have 12 here. Then the length of the side is 42 by 11. Now, this same pyramid and another conical container, they share the same height. So, if you extend the height of the pyramid to assign to our cone, the conical container, we can draw our cone. So, we have a cone with a circular base. Then, vertex. So this cone is also 12 centimeters high. So the height is also 12. Then we are asked to find the radius of the cone. So radius R here. This is the radius R. That's what we are looking for. But we are noting that both the pyramid and the conical container, they have the same volume. Not just only the same height, they have the same volume. So the volume of pyramid we have been given to be also equal to the volume of the conical container. So what is the volume of a pyramid and what is the volume of a cone? If we can express these two volumes and equate them together, we'll be able to find the radius of our conical container. So now, the volume of a pyramid, you say volume of pyramid, we are told is equal to the volume of cone. The formula for the volume of a pyramid is given as 1/3 multiplied by the breadth of the base, multiplied by the length of the base, multiplied by the height of the pyramid. Volume of the cone is 1/3 pi r square h. R is the radius of the circular base and h is the height of the cone. So if you put in these values, which you have already, the base is 42 multiplied by the length 11 multiplied by the height, which is 12, is equal to 1/3 pi is 22/7. The radius is what we are looking for, and the height is also 12, the same height. We can cut out similar values. 12 can cut out, 1/3 can cut out, 22 can be, 11 can be used to cut 22, we have 2. So we are left with, 2 can go in 42, 21, 2 can go in 22, 1. We are left in 21/1 is equal to r square over 7. So if you cross multiply, r square will be 21 multiplied by 7. And that will be, now 21 multiplied by 7 is 147, meaning that r is the square root of 147. But now 147, if you want to express in factors, it will be 3 times 7 times 7, because 21 is originally 3 times 7. So that means r will be 7 root 3. And we are told to leave our answer in radicals, in short form. And that is our answer. Here, in question number 3, we are given the frequency distribution table that shows the range of prices of a brand of car and the corresponding quantity that was demanded. We are to represent this information in a histogram and use that histogram to determine the value of the most preferred selling price. Now, for us to draw a histogram, we need to get a table of class boundary, and the class boundary will feature the upper class boundary and the lower class boundary. So if we are to express this, our information on the table, we have the price in millions of naira, and then we have the class boundary. The class boundary we are going to be taking as a range between the lower class boundary and the upper class boundary. So from lower class boundary to upper class boundary, then we are going to be having a number of vehicles, which is something similar to, let's say, frequency. That's the frequency. So now, if we are to put in our values as given in the table, we have between 1 to 1.9 million, 2 to 2.9 million, 3 to 3.9 million, 4 to 4.9 million, and 5 to 5.9 million. Now, the class boundary will be the value when we take 0.5 out of the first entry and add 0.5 to the last entry. So we are going to have 0.95 to 1.95, 1.95 to 2.95, then 2.95 to 3.95, 3.95 to 4.95, and then 4.95 to 5.95. Now, having this, you can put in the values of the number of vehicles. Put in that values. Now, with this now, we can say we want to go ahead to obtain our histogram. Now, having the axis as the number of vehicles against the price, we are going to be plotting with the class boundary. So we need to put in the values for the class boundaries and then the number of vehicles on the vertical axis. If you label all those, right, 100. So now, what I'm going to be taking is that for the number of vehicles, when we have number of vehicles is in the first value, we have 23. And then the class boundary is 0.95 to 1.95. We are going to be working with the upper class boundary and the lower class boundary. So 23 will be in between here, 20, 22, 20, okay? To be here. And then we can draw from 0.95 to 1.95, that is 23. Then 1.95 to 2.95 is being plotted against 48. So with gradation of 2, 48 will be just before 50. So here, 48 and 1.95 to 2.95. Then 107 will be located up here. 107. Then 2.95 to 3.95. Alright. Then 90 to be plotted against 3.95 to 4.95. Then 32 is located here. We plotted against 4.95 and 5.95. So with these bars, we just join them together. For the histogram, why it's different from the bar chart is that all the bars, they are touching one another. There is no space in between the bars. So we can finish our histogram by drawing all our rectangles touching one another. And with that, we have gotten our histogram. Now, we are asked to use this histogram to determine the most preferred selling price for the brand of car. To do this, we look at the highest bar, now our highest bar, and then we cross from this highest bar. What we are going to do is that we cross from the two entries to the left and to the right of it, as being shown. Yes. And then the point of intersection, we can trace down to get the value of that point of intersection. And that will be the most preferred selling price for the brand of car that will yield maximum profit for the seller that is actually having these statistics at their custody as a report of their sales. So if we trace down that point of intersection, yes, we can notice it on the horizontal axis, which is for the price. Now we have initially, we have 2.95, and then we have some entries. If we grade this between 2.95 and 3.95, this will be 0.75. And then adding 0.75 to 2.95 will give us the most preferred price in millions of naira. So that will be 2.95 plus 0.75. And that will give us 3.7. But remember, we are working with millions of naira. So that will be 3,700,000 naira. Okay. Our question number 4 is on an isosceles triangle in which you are given the perimeter to be 28 centimeters and we are to find the value of x and y and the length of the sides of the triangles. Now, when we're talking about isosceles triangle, a major property that we need to note that will help us in solving this question is that two sides of the isosceles triangle are always equal. And here, those are the sides that were notched that were given in the diagram. So we can say 4y is equal to 6y minus 2x plus 1. And if we are to collect like terms, from this, let's collect the like terms. So we have 2x plus 4y minus 6y is equal to 1. That means 2x minus 2y is equal to 1. We can have this as equation 1. The other is equation 1. The other information we are given is that the perimeter of the triangle is 28 centimeters. And now, when we talk about the perimeter, that means we are summing all the sides of the triangle. So here we have all the three sides. If we sum them to give 28. So we can write that out to say 2y plus x plus 4y plus 6y minus 2x plus 1 is equal to 28. Now, this understanding of the property of isosceles and the definition of a perimeter had seriously helped us to try and evaluate this. So from the perimeter, if we collect the like terms, x minus 2x will be minus x, 2y plus 4y plus 6y will be 12y. So we have plus 12y. Then we have, that will be 28. 1 moving to the other side will become minus 1. So we have minus x plus 12y is equal to 27. This we can tag as equation 2. As equation 2. Now, a set of simultaneous equations that we want to solve, we can make from this equation 2, we can say we want to make x the subject of the formula. And if we do that, it will give us 12y minus 27 is equal to x when x moves to the right-hand side. So, let's say this we can call a new equation for x that we can use in equation 1. So, using s is equal to 12y minus 27 in equation 1, we want to use that in equation 1. So, where we see x, we put in this new value. So, that will be 2 into 12y minus 27 minus 2y now minus 2y is equal to 1. So 2 times 12y will be 24y minus 2 times 27 is 54. Then this other minus 2y is equal to 1. 24 minus 2y is 22y equals to 1. When 54 moves to the other side, it becomes plus 54, which is 55. Y will give us 55 over 22 by this, and 11 can go in the 2. We have y is 5 over 2. Then x, initially we got it to be 12y minus 27. So if you want to put in the value of y, that will be 12 multiplied by 5 over 2 minus 27. And 2 can go in 12. So we have 6 times 5 is 30 minus 27. And x will be 3. So we've been able to find the value of x and y to be x is 3 and y is 5 over 2. So now we want to look at the length of the sides of the triangle, which is our question number B. But initially we got x to be 3 and y to be 5 over 2. So for each of these sides of the triangles, we can evaluate the value of each side. For example, for PQ, the side PQ was given as 2y plus x. If you are to put in the value of y and x, that will be 2 multiplied by 5 over 2 plus 3. 2 will cancel out, that will be 5 plus 3, which is equal to 8 centimeters. So PQ is 8 centimeters. Then, recall that we are told that our triangle is an isosceles triangle. So the side QR and the side PR, they are equal. And we can use the equation for any one of them. We can say 4y, and that will be 4 multiplied by 5 over 2. 2 we cut 4 to be 2. So we have 2 times 5, which is 10 centimeters. Or we can say we want to use the side PR, which is 6y minus 2x. That will be 6y minus 2x plus 1. And we know that that is 6 into 5 over 2 minus 2 multiplied by 3 plus 1. So 2 can go in 6. We have 15 minus 6 plus 1. That will be 15 minus 6 is 9. 9 plus 1 is 10. So we got 10 as in the previous case. And with that, we have solved our question number 4. In question number 5a here, we are told that we have to find the range of values of x that satisfy the inequalities 5 minus x is greater than 1 and 9 plus x is greater than or equal to 8. Now, for the first entry, 5 minus x is greater than 1. If we take 5 to the other side, minus x will be greater than 1 minus 5, giving us minus x is greater than minus 4. But now, we can say we multiply all through by minus 1. Now, the implication of this is that the sign of the inequality will change. If you are dividing or multiplying by a negative number while we are working with inequality, the sign will change. So here, if you multiply through by minus 1, it will be x is less than 4. So now, for the second inequality, 9 plus x is greater than or equal to 8. That means you can say when 9 moves to the right-hand side, x will be greater than or equal to 8 minus 9. And that means x is greater than or equal to minus 1. Now, to get this range of values, we can say we want to plot our number line. As a rule of thumb, I personally advocate that students should draw their number line in their question. So, just drawing the number line and showing the values that we got, if you label this number line, then here we have x is less than 4, okay, that's an empty circle. X is greater than or equal to minus 1. Because or equal to is there, that will be a solid circle, and the two we can join together. Now we can write this as a form of a single inequality expression, or we can write out the range itself. So for here, the range, minus 1 is inclusive, so we have 1, 0, 1, 2, and 3. 4 is not inclusive because it is not equal to 4. It is only less than 4. And that is our solution. So question number 5b. In this diagram, we are given that O is the center of the circle, PQ and QR, they are equal in length, and PSR is 56. We have to find angle QRS. Now, locating QRS on the diagram, that is being shaded in red. That's angle QRS that we are told to find. But now, looking at this question, how best can we go about it? There may be quite a number of ways to employ. But since we are told that PQ and QR are equal, we can form an isosceles triangle from that PQ and QR, and the base angles of isosceles triangles, they are properly equal. So angle QPR and the other angle PRQ, which we are denoting as X, they are equal. And the reason is that they are base angles of an isosceles triangle. That's one of the properties of an isosceles triangle. Is base angles, they are equal. So now, having known that, if we look at the center of the circle also, and we look at the diameter, we also notice that the angle PRS is going to be 90 degrees. Now, angle PRS is a right angle, is 90 degrees. And why? The reason is because this is the angle that is subtended at the circumference by a diameter. The angle on a diameter is a straight line, that's 180. Half of it is 90, which is subtended at the circumference of the circle. So now, we have gotten PRS to be 90, and then we have QR, we have PRQ to be X. Our QRS that we're asked to find, from the diagram, we can see that it will amount to X plus 90 degrees. So our task has been simplified to finding the value of x because we know 90 already. To find s, if you look at the angles being shown in green, you will notice that they are opposite angles of a cyclic quadrilateral. So angle RSP, which is 56, plus angle RQP, the other one in green, the two, they will sum up to be 180 degrees. And that is from the fact that the opposite angles of a cyclic quadrilateral, they are supplementary. Supplementary meaning that they add up to 180. Now, these are basic rules of the circle theorem that normally help us to solve this type of questions. So, with this expression that we just wrote, we can say 56 plus this angle, if we call it A, 56 plus A is 180 degrees, such that A is 180 minus 56, and that will give us 124 degrees. So now, we've gotten A, but looking at triangle, the isosceles triangle, if you consider the triangle QPR, we know that the sum of the angles of a triangle is 180 degrees. So A plus the 2x, they are going to give us 180 degrees because the sum of angles of a triangle is 180. So we can solve for x from here. Our A is 124 plus 2x is equal to 180 degrees. Therefore, our 2x will be 180 minus 124, and that is 56 degrees, so that x is 56. X will be 56 divided by 2, and that will be 28 degrees. So now our QRS that we are looking for, we can solve since we now know the value of x, and that angle QRS will be x plus 90, which is 28 plus 90, and that is 118 degrees. And with this understanding of the theorems of circle and the property of isosceles triangle, our question is solved. Here in this question number 6, a textbook company was discovering that their profit from selling their book is given by y is equal to s squared over 8 plus 5x. And x is the number of textbooks, y is the corresponding profit in Ghana cedis, y is the profit in Ghana cedis. Okay, and then that y was given as 20,000 cedis. So if we put in that value of y into our equation, we have 20,000 is s squared over 8 plus 5x. Now, that will give us 20,000 over 1 is equal to, finding the LCM of the right hand side, s squared plus 8 times 5 is 40, so we have 40x. If we cross multiply, that will yield 160,000 will be s squared plus 40x. And to form a quadratic equation, that will be s squared plus 40x minus 160,000 is equal to 0. So we have our quadratic equation from the word problem that we are given. So these are quadratic equation. Now, in the question number 2, we are to use the quadratic formula. Notice we are given what we need to use. We are to use the quadratic formula to find the number of textbooks that will be sold to make the profit. And x, we have been told, is the number of books. So x is what we solve for in this quadratic equation. Now, what is the quadratic formula? The quadratic formula is being expressed that x is a minus b plus or minus square root of b squared minus 4ac over 2a. Now, if you are to write the general format of the quadratic equation, it's given as as squared plus bs plus c is equal to 0. So, meaning that we can find the value of A, B, and C by comparing this. So we have these values for A, B, and C. And if we are to plug in that into our quadratic formula, since we know these values, let's plug it into our quadratic formula. We'll have x will be, b is 40, so we have minus 40 plus or minus square root of b square. B square is also 40 square minus 4 multiplied by A is 1. Then C is minus 160,000. Note, not 160,000, it's minus 160,000, all divided by 2A. And 2A is 2 times 1. So bringing our calculator, we want to put in these values. 40 square, let's do it straight. Minus times minus will be plus, so it will be plus 4 multiplied by 160,000. That's 641,600. So if we are to find the square root of that, let's write it out first. Minus 40 plus or minus square root of 641,600 over 2. So this will give us minus 40 plus or minus, what's the square root of our, so that will be 800.9993, 800.9993, 994 if you round up over 2. Now, we have plus or minus, but now we need to notice something in this question. We are being told that it is a profit, and since it is profit, and this is a mathematical expression of our profit, then the value needs to be positive. We don't need to take the negative value. So we can just say, for our question in particular, minus 40 plus 800.9994 over 2. And that will be equal to and that will be equal to 380.4997. Now, in our question, we're asked to find correct to the nearest whole number, the number of textbooks, and these textbooks are being sold in thousands. So, we multiply this value by 1,000. So, we have, this will be 380.4997 multiplied by 1,000. Then correct to the nearest whole number, that will give us 380,500 textbooks. And that is our answer. Question number 6b. The angle of elevation of the top of a tree from a point P on the same ground level as a foot Q is 28 degrees. A bird perched at the point R halfway up the tree. We have to represent the information in a diagram and find the angle of elevation of R from P. So if we are to draw out our diagram, this is our tree, and then on the ground level, we are told that there is a point P on the ground level, and there is an angle of elevation to the top of the tree. So this was given as 28 degrees. Then halfway up the tree, there is a bird that perched, let's say, on one of the branches of the tree. Our bird here, on the branch of the tree, halfway through the length of the tree. So if the tree length is L, half length of the tree will be L over 2. Okay, and the other length will be L over 2. So we are now labeling the top, then the point where the elevation is being done, and the base of the tree. Then the point where the bird is perched is R. So now we have our pictorial diagram. We can just do a schematic from here. Let's do our schematic. Just giving us the basic. Okay. We have now is a right angled triangle. This is 28 degrees. Is P, Q, and T. Then point R. Halfway between T and Q is R. We have L over 2 and L over 2. And we are asked to find this, the angle of elevation of R from P. So we can call that theta. We are asked to find theta now. Okay. With this information, how best can we go about finding the value of theta? If we call the adjacent of our diagram, we call it x. You can look at the two triangles, the bigger triangle and the smaller triangle, and find a relationship between our theta, our x, and the length of the tree and its half length. And from these triangles, like from the bigger triangle PTQ, you can say that we have the opposite and we have the adjacent. You can say we want to use the value of tan theta, but for the bigger triangle is tan 28. Tan 28 will be opposite over adjacent, and the opposite for the bigger triangle is L. That's the whole of the opposite. So that will be L over the adjacent, which is x. So from here we can say that our x, which we introduced ourselves, is L over tan 28. Okay. Now we are doing this because that x we are also going to use from the other smaller triangle PRQ. So from triangle to PRQ, we can say that tan theta, the theta we are looking for, is also equal to opposite over adjacent. But the value of the opposite now is L over 2. This is its own opposite, L over 2. L over 2 over the adjacent, which is x. Now, with this now, and we have gotten the value of x before, we can say tan theta will be, we have something like L over 2x. Now, if I want to write this out so that I don't make mistake, it will be L divided by 2x, and that will be L divided by 2L. X is L over tan 28. So, if I turn that to multiplication, I have L over 1 times tan 28 divided by 2L. The L will cancel out such that my tan theta is tan 28 divided by 2. So if I bring in my calculator now, so you want to get tan 28, that's tan 28 divided by 2, 0.2659. 0.2659, 26585, which will be 2659. So theta is arctan 0.26585, and that will be arctan, our answer, 14.8879756. But we are told to find that value correct to the nearest degree. That will be approximately 15 degrees. And that is our answer. In question 7a, we want to work with integration, but recall, we want to find the integral of ax raised to the power n. That will give us a, which is the coefficient, multiplied by adding one power to x and dividing by that new power. And using that, we can solve our question 7a easily. So now, integral, the definite integral between 2 and 1 of 2s cubed minus 4s plus 6, integration with respect to x will be, now for the first value, we have our coefficient 2, just like a. Then x raised to power, instead of just 3, we have 3 plus 1, and also divide by 3 plus 1. Then 4x raised to power 1 plus 1 divided by 1 plus 1 plus 6. Now, ordinary 6 is as if we are multiplying by 6 multiplied by x raised to power 0 because x raised to power 0 is 1. So we'll have between it as 6 multiplied by x raised to power 0, then we add 1, then divide by the power. And we are taking this between 2 and 1. Now, if we want to evaluate this, that will give us 2 times x raised to power 4 all divided by 4, and 2 will cut 4, minus 4 multiplied by x squared over 2. 2 will also cut 4, then plus 6 multiplied by x over 1. And by the time we've expressed this, it will be x raised to power 4 over 2 minus 2x squared plus 6x, and we take the integral value between 2 and 1. So first, we want to take the value of 2, and then we'll evaluate, and then take the value of 1 and subtract from that initial value of 2. So for the 2, we have, this will be, instead of x, we have 2 raised to power 4 over 2 minus 2 multiplied by 2 raised to power 2 plus 6 multiplied by 2. All of these minus now the values for 1. 1 raised to power 4 divided by 2 minus 2 multiplied by 1 square plus 6 multiplied by 1. Now 2 raised to power 4 is 16. 16 over 2 will be 8. That is, we have 8 minus 2 raised to power 2 is 4 times 2 is 8 plus 6 times 2 is 12 minus 1 over 2 minus 2 plus 6. So solving this, the 8 will nullify each other. We have 12 minus, now 6 minus 2 is 4. 4 plus half is 4.5. So we have 12 minus 4.5, which is 7.5 as our answer. So now we want to find P, giving P inverse as this matrix. But first, we need to know that P itself is the inverse of the inverse of P. P is the inverse of the inverse of P. So meaning that in this question, we are just saying that we are finding the inverse of 1 over P, and which is P. So all we need to do is just to find the inverse of the matrix that we are given. Forget that we are talking about inverse. Just find the inverse of this. So P will be the inverse of P inverse, and that will be the inverse of the whole of the matrix. So with this, we say the inverse of the matrix. Now our P will be 1 over the determinant of P inverse multiplied by the adjoint of P inverse. So our question now is to determine the determinant of P inverse and the adjoint of P inverse. Now to get the determinant of P inverse, first the determinant of P inverse, that will be, we take the entity in the leading diagonal, which is being shown in green, and multiply them together. So we have minus 1 multiplied by minus 3. Then we take the product of the entity in the other diagonal, and we said the first one minus 4 multiplied by 1. Now, minus 1 times minus 3 is 3. Then minus 4 times 1 is 4. So the determinant of P inverse is minus 1. So our next task is to find the adjoint of P inverse. And how do you find the adjoint of P inverse? We find the adjoint of P inverse by first taking the entity in the leading diagonal and swapping them. So here we'll have minus 3 and minus 1. Then changing the sign of the other entity in the other diagonal. So here we have minus 1 and minus 4. And with these two values that we have, the determinant of P inverse and the adjoint of P inverse, we can find the value of P now to be 1 over the determinant of P inverse, which is minus 1, multiplied by the adjoint, minus 3, minus 1, minus 4, and minus 1. Now, by the time we find this and multiply through by -1, we have 3, 1, 4, and 1. In this question, we're told that a container in the form of a cone is resting on its vertex. We need to know this, and we're talking about a conical container resting on its vertex. So it is full when 4.158 liters of water is poured in it. Then if the radius is 21 centimeters, we are to represent the information in a diagram and calculate the height of the container. So if we are to draw out our container with its circular base at the top and its vertex now being down, we can denote the radius of the container, which is given as 21 centimeters. And then I think it would just be good for us to identify the height which we are looking for. And then we are told that it's resting on its vertex. So now, normally the vertex is supposed to be up, but now since it's resting on its vertex, we have the base to be up and the vertex is down. So with this, we've represented the information in a diagram. We are now to find the height of the container. But notice that we've been given the volume of the container, and the volume was given to be 1.58 liters. And then we also know the radius to be 21 centimeters. Now we have 21 centimeters and 4.158 liters. They are not in the same unit. So as a rule of thumb, the first thing to do is to convert the liters to centimeter cube as a volume, so that we can use the same values and continue our calculation as appropriate. So by conversion, we can say that this volume will now be 4.158 times 1000 centimeter cube, because 1 liter is constituting 1000 centimeter cube. So 4.158 liters will be 4.158 times 1000 centimeter cube, and that will be 4,158 centimeter cube. So this is the volume of the conical container. And if you recollect, the volume, since the volume of a cone is 1/3 pi r square h, then we can equate this volume, and we know the value of r, we are looking for h. We also know pi. Then 4,158 is equal to 1/3 multiplied by pi, which is 22/7, multiplied by the radius, the square of the radius, times 21 times another 21, multiplied by the height that we are looking for, h. So with this, we can solve for our h. We just bring in our calculator and find the expression for the right hand side. 1/3 multiplied by 22/7 multiplied by 21 multiplied by another 21. That will give us 462. So we have 4158 is equal to 462h. So h will be 4158 divided by 462. And using our calculator, 4158 divided by 462. So the height of the conical container is 9 centimeters. And that's all about our question here. So that's question A. So now question number B. We are now told that a certain amount of water is drawn out of the container such that the surface diameter of the water drops to 20 centimeters, and we have to find the volume of the water. Now we are told the surface diameter, and we have to find the volume of the water that is drawn out. So how best can we interpret this? I will again bring in the diagram of our conical container, but now bigger to actually show our details. And with this diagram, initially we have our radius. The radius of the whole container, it was initially given to be 21 centimeters. Now we have found the height h of the conical container to be 9. The height we just found to be 9. But now we are told that some water were pulled out and then the diameter of the surface of the remaining water drops to 28 centimeters. Now, not to be confused, we are given the diameter, but we are working with our radius. Now, radius is diameter divided by 2, so we have 28 over 2, which is 14 centimeters. So now, our new radius, after taking out some volume of water, the new radius will now be 14 centimeters. So, if we are to denote that, this is 14 centimeters. Now, we don't know the height of the new volume of water in the cone. We will do best to find that out so that we can use to evaluate the volume of the remaining water, and then we can subtract from the total volume to get the volume of the water taken out. So now what we are having is that at this point, the water level, when the radius is 14 out or the diameter is 28 centimeters, the water level is being denoted in blue. You just want to get that information out. The water level in blue. Now, the height of that water level we can take to be m, which we are going to be evaluating first. So now we have, if you look critically, we have two similar triangles. A bigger triangle with two sides 9 and 21, and a smaller triangle with two sides m and 14. We can use the principle of similar triangles to find the value of m because they are actually similar triangles. So by the principle of similar triangles, the ratio of the sides are going to be constant in this case. So we can take let's say we want to take m divided by 9 will also be 14 divided by 21. It's as if you are taking the opposite, the ratio of the opposite over the ratio of the adjacent. So if we cross multiply, m will be 9 times 14. 14 times 9 divided by 21. We can cut. So our m is 6 centimeters. So the height of the water, the remaining water in the cone, in the conical container, is evaluated as 6 centimeters. Now we can now go ahead to find the volume of water, the amount of water that was taken out of the conical container. And to find that, if you are denoting that volume that was taken out at the top of the conical container in our red ink, just as it's being shaded, now we can find the volume of this water, the amount of this water that was drawn out. We can get it by subtracting the remaining amount in the conical container from the total amount of water when the container was full. So the volume of water drawn out will be equal to the volume of the container when it was full, which was given as 4.158 liters, minus the remaining volume of water in the container now, that is being denoted with radius 14 and height m. So that will be the volume of cone when full minus the volume of the remaining water. The volume of the remaining water. So now, if you want to get that, the volume of the cone when full in centimeter cube, mind you, it was given in liters, but we have to use in centimeter cube. So we did the conversion initially, and we found it to be cube 4,158 centimeter cube. Now minus the volume of the remaining water, we can find by saying 1/3 pi r square h. Pi r square h. Now the pi is a constant. Our radius now is 14, and our h is m, which is 6 centimeters. This is the height of the remaining volume of water. So just using this, we can now plug in these values and say that the volume of the water that is drawn out now will be 4158 minus 1 over 3 multiplied by pile is 22 over 7 multiplied by the radius square is 14 times 14 multiplied by the h, which is 6. We found it to be 6. So if we bring in, if we want to cut 7 can go in 14 in 2, 3 can go in 6, also 2. So we have 22, 14, and 4. So we can say 22 times 4 times 14, that is 1232. So we have this to be 4158 minus 1232, and by the time we evaluate that will give us 2926 centimeter cube, and that is a solution to our problem. In this question, we are given the distribution of marks scored by 2 students in a test, and we are to construct a cumulative frequency table for the distribution, then draw a cumulative frequency curve or OGIF, and then use that to estimate the median and the probability that a student selected at random obtained distinction if the lowest mark for distinction is 75%. So now, in our first assignment, we want to get the cumulative frequency table, and the feature of the cumulative frequency table will involve the marks, the class boundary, the frequency, then the cumulative frequency. So if we are to go ahead and draw that, we have the marks, we have the class boundary, the lower class boundary and the upper class boundary. Then we have the frequency, then we're going to have the cumulative frequency. These are the entries that constitute a cumulative frequency table. Now, if we go ahead to say we want to populate our table with the information that we're given from the question, we have 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. All of these are the range of the marks that was scored by the students. So down to 90 to 99. Then we can go ahead to finish up our table by estimating the class boundary, then putting in the frequency, then evaluating the cumulative frequency. Now, for the case of the class boundary, we have 10 as the least mark in the first case and 19 as the highest mark. We subtract 0.5 from 10 and add 0.5 to 19 to get upper class boundary and the upper class boundary respectively, and we do this for each of the entries as being shown in the table. So we have 39.5 to 49.5 and 49.5 to 59.5, and like that we can populate the table of the class boundary for each of the range of mark that was scored by the student in the test. Then our frequency, we're given this frequency 4, 7, 12, 18, 20, 14, 9, 4, and then 2. Now, to get the cumulative frequency, we add each of the entries, like 4 plus 7 is 11, 11 plus 12 is 23, and 3 plus 18 is 41, 41 plus 20 is 61, 61 plus 14 75, 75 plus 8 84, 84 plus 4 88, and 88 plus 2 90. The cumulative frequency is obtained by adding the entries and adding them cumulatively. The new entry you add to the sum of the previous ones and we'll get our cumulative frequency like that. So we've gotten our cumulative frequency table. We can now go ahead to draw our cumulative frequency curve. So here on our graph, we'll plot the cumulative frequency against the marks that was obtained, but we're going to be using the class boundary for the marks, not just the mark that was given. So on our horizontal and vertical axis, we can have our cumulative frequency on the vertical axis and the marks on the horizontal axis. I'm going to be using 2 centimeters to represent on the horizontal axis, on the marks axis. In that, I will say 2 centimeters will represent 9.5 units. I'm not starting from 0 in that case, so it's not linear at the beginning, but subsequently there are gradations of 10, 9.5, 19.5, 20.5, 29.5, 39.5, 49.5, and on down to the last entry we have 99.5. Then on the vertical axis, I'm going to use 2 centimeters to represent 10 units. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So now, what we need to plot is the values of the upper class boundary against the value of the corresponding cumulative frequency. So now, that means that we will start our first entry with 19.5, the first upper class boundary, and then the cumulative frequency is 4. So here, we'll have 4 and 19.5, 4 on the vertical and 19.5 on the horizontal. And in the same principle, we can trace each of the entries. Then the next one will be 11 and 29.5. 11 is here, 29.5, okay. Then the next one is 23 and 39.5. And then 41 and 49.5. And then 61 and 59.5. Then we have 75 and 69.5, 84 and 79.5, then 88 on the vertical axis and 89.5 on the horizontal axis. Here. Then finally 90 on the vertical axis and 99.5 on the horizontal axis. Now, with our set of points that we have noted, all we need to do is to use our French curve to join all these points together. But we need to know that we are plotting the upper class boundary against the cumulative frequency. That's how we got the locus of points that were noted on the graph. So, if we are to join all the points together, let me use blue ink. So, find the line of best fit and join all of them together. A French curve will be quite useful here, or on the graph paper, if you can get a flexible material, you can actually make sure that all the points are fitted together. Wow, okay, good. So with this, we've been able to plot our cumulative frequency curve, also known as OGIF. My scale is that 2 centimeters is representing 10 units on the horizontal axis and on the vertical axis. Only to note that on the horizontal axis, the one for the marks, we are not starting on a scale of 0 because the first entry there is 9.5, not 10. And with that, we've been able to come up with our graph, and then we can move on with the other questions that we are asked to solve for. Now, this is our scale. This is the scale, and we're done with that. So, now, in our next question, we're asked to find the median. We're asked to find the value of the median mark. Now, what we need to note is that cumulatively, all of our frequencies, they add up to 90. The frequencies add up to 90, and the median will be half of that 90, and that is 45. So we go to our vertical axis and locate 45. So this is 45. Then we trace to the curve we can trace 45 to the curve, so that we can get the corresponding mark that is in line with our 45 on the cumulative frequency, which is the median, the 50%. And from here we can see this gradation, that median is 51.5%. So 45 on the cumulative frequency curve, on the cumulative frequency axis, corresponds to 51.5 on the mark axis. So the median mark from this cumulative frequency curve is nothing but 51.5%. So good. Now, our last question on this particular question that we are solving is quite tricky, but we can look at it together and get the resolution out. We are told that the distinction starts from 75%. So now, going to the mark, we can try and mark off the 75% point. We have 69.5, then we have 79.5. 75 will be around here. Yes, around here. So from there, we can trace that up to our curve. This is 75%. That's the least mark for distinction. You can trace it up to our curve. And then we can see that correspondingly, this is giving us 80 on our cumulative frequency axis. Now, if 75% is amounting to 80, and of course, that's the least mark, then some can actually get higher than that. And then the region that is being shaded, you don't need to show this in your exam. I'm just using this for explanation purpose. The region constitutes the region of those who actually got distinction. So these are the distinction marks. And then correspondingly, this is the distinction frequency for those marks that we have identified. So now, we have to find the probability that a student selected at random would have scored a distinction mark. Now, normally, we know that the definition of distinction is our desired outcome divided by the total possible outcome. So, probability of choosing distinction student is the possible outcome, which is our desired outcomes here, divided by the total of the possible outcome. So, the total of the outcome. So here, our possible outcome will be the difference between 90 and 80. That's 90 over 80 over 90. And solving that, we get it as 1 over 9. That is the probability of picking a student that scored distinction. Here we are given a question that we should use only a ruler and a pair of compasses to construct a quadrilateral, given the sides of the quadrilateral and one of the included angles. Then we have to draw a perpendicular from one point to another, and then we have to measure some points and move on with our question like that. Now, like this, what we are going to note first and foremost is that how do we interpret our question? How best can we go about resolving this, given these four sides? Now, we'll notice that there is an included angle that is given as angle PSR is 90 degrees. Now, that is a clue to what is going to help us. Because now, if you say we just want to draw some side and we are not noting the angle, then how are we going to know the inclination of one of the side to the other? So the best bet for us is to start with the angle that we have been given. And so here, we have been given angle PSR. And since we know angle PSR, we can go ahead to say we want to construct angle PSR, which is 90. Now, how do we construct an angle of 90 degrees? We know that 90 degrees is half of 180 degrees, and 180 degrees is angle on a straight line. So, if we take our point that we want to note and we draw a straight line, we are taking our point. Since we are giving angle PSR, that means this point is going to be point X. Now, from point S, first and foremost, you want to notice the angle on a straight line, which is 180 degrees. So taking our compass into the point, we want to draw a semicircle, which is 180 degrees. And once we have that semicircle, we can now go ahead to say we want to bisect. Bisect means we want to divide it into two equal parts. If we bisect it, then we want to get half of 180, which is 90 degrees. So we have our 180 degrees already there at our point S, which we are going to label. Now to bisect, we take our compass to one of the edges, increase the radius, and mark off an arc at the top of the diagram. And then we go to the other end of our semicircle, maintaining the same radius as we used just previously. We're also going to draw another arc such that the two arcs, they cut each other. Now, these two arcs are the point where they intersect, and the point that we are taking initially, which is our point S, if we draw a straight line through the two of them, with that we would have bisected our angle 180 degrees to obtain 90 degrees. So if we join those 2 points, the point where we are taking our semicircle as a center, and then the two arcs, at this point we have been able to bisect angle 180 degrees such that we have 90 degrees. So we can label that, and then we can bring in our label for point S. So now, since we have been able to get angle PSR, now we can look at PS is 8 centimeter and SR is 12 centimeter. Now let's go with the SR is 12 centimeter, the larger side. So from point S, we want to measure 12 centimeter. If we take our compass to our ruler and we locate 12 and 0 as a mark-off point, we can now go to point S and put the pin of our compass and then cut an arc at the other end. Let's put to point S and cut an arc at the other end, noting that this is 12 centimeters. So this is point R, so that our SR is now 12 centimeters. Then since that is done, we can now say we want to go to point PS now. At point PS, that will be the vertical line. So we want to mark off a measurement of 8 centimeters. Taking our compass again, starting from the origin. Okay. Let's straighten that out. Okay. We want to measure 8 centimeters. All right. So we take our pin to point S, pin at point S, and then we mark an arc just like this, and that measurement is 8 centimeters. We can also label that appropriately. Now this will be point P, and the measurement between P and S is 8 centimeters. So now the other length of the quadrilateral, we are not giving the angles, but we are only giving the length of the sides. We are giving like PQ is 6 centimeter and QR is 11 centimeter. So what we need to do is to mark off each of these lengths and then draw an arc, and wherever the two arcs meet, we will know that we are getting this our length. So if you are to take first, let's take 6 centimeters. So we can go to our point P, and then to mark off Q, which is 6 centimeter, we can draw an arc, draw our arc, and between P and that arc is a set of points that are 6 centimeters apart from P. Then to get our QR, we can also go and measure from our ruler a length of 11 centimeters. And with that 11 centimeters, we can go to point R, which we have defined already, and then try and mark off an arc that will cut the initial arc that we just drew. So here we have between R and this new arc 11 centimeters. The point of intersection will be the point that will correspond to PQ being 6 centimeter and QR being 11 centimeter. So if we bring in our ruler to join these points here between P and the intersection of the two arcs, our ruler getting the line of best fit. Okay, we can draw our straight line, and that will be line PQ. So our new point that we're having is line PQ, but then we also have the line QR, also bringing in our ruler to join the 2 points with best fit. Now this will be line QR. So we can go ahead to label our diagrams and complete our quadrilateral. So we are to note our point Q. Okay, this is point Q now. So we have gotten QR as 11 centimeters and PQ as 6 centimeters. So with that, we have been able to finish question A1, but then we are asked to find a perpendicular from Q to cut SR at K. Now Q is at the top, SR is at the base. We will draw an arc that will first cut SR. Now with this arc that will cut SR, what we are going to have is this arc like this, and then we can take the 2 points at which that arc cuts the line SR so that we can bisect that arc and link it up with the point Q. So if I take this and make an arc and then go to the other side onto that arc that I drew, and also I want to mark another arc. Okay, now this intersection of the 2 arcs and point Q, if I join them with a straight line, that will be a perpendicular to the point, to the line SR. So bringing in my ruler from Q to line SR, I can draw a straight line. Okay, and that straight line is a perpendicular from Q to cut SR at the point K. So with that, our construction is quite done. All we need to do now is to measure QK, and with our ruler, we can notice that, okay, from K down up to Q, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be 9.2 centimeters. So we can input our values as requested, that the line QK is giving us a measurement of 9.2 centimeters. And then we're also asked to find the angle QRS. So noting our QK, we can bring in our protractor. Our protractor will be used to measure angle QRS. So R is the midpoint. If we put the origin of the protractor there, we can see from SR to Q, we are having the angle QRS to be 56 degrees. In this question number 11, we are asked to complete the addition and multiplication table in modulo 5 on the sets 2, 3, and 4. Now, before we go ahead, if you remember the wall clock with its gradation of hours, normally, if you have our wall clock like this and we want to give our time, we can say we have, when it's 2 o'clock, we know it's 2 o'clock, 3 o'clock, 4 o'clock, 8 o'clock, 9 o'clock. But in a scenario in which we are talking about something like 15 hours, what we do ideally is we number from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. Now, 12, 13, 14, 15. And we say that 15 hours is synonymous to 3 o'clock. What we notice is that on our 12, we round off our counting, and then we start with 1, 2, and 3. In the same way, we can tag 17 hours as 5, and then we can tag 20 hours as 8. So now, this is obtainable because we're actually rounding off at 12. So 12 we can take as our benchmark, and any number after 12 we can round up to start all over again from 1, 2, 3 and go. This is the concept of modulo that we are going to be working with in this question. But here, instead of working with modulo 12, we are going to be working with modulo 5. Modulo 5. So now, that means that at every point at which you get to 5, we round off at 5. So we don't have 5 at all. We can only have 0, 1, 2, 3, and 4. And that will make a complete circle before we go over our circle and start all over from 1 again. So in that particular instance, that means that if you want to tag, let's say, number 7, 1, 2, 3, 4, 5, 6, 7. 7 will be congruent to 2. That is the language we use when we're talking about modulo. 9 will be congruent to 4. And then, let's say 12, 9, 10, 11, 12. 12 will also be congruent to 2. Now, all these are obtainable whenever we are working with mode 5, which is the mode that will be working in our question, modulo 5. So, with this background, we can also look at a better means of expressing this. Normally, we can find our expression by just using the remainder concept. Like, if we are dividing by 5, like 4 times 3 normally is 12. But now I want to use it in modulo 5. We are doing that in modulo 5. We know that 4 times 3 originally is 12. But if we take 12 in modulo 5, what we are going to have is 12. Let's say we divide 12. We use 5 to divide 12. That will be 2, remainder 2. So the value of 4 multiplied by 3 in mode 5 is 2, which is the value of the remainder when 12 is divided by 5. In the same way, you can say 4 times 4 in mode 5. That will be 16. But now, if you want to find 16 in mode 5, you can say 16 divided by 5. 16 divided by 5 is 3, and we will have 1 as the remainder. So 16 in mode 5 is actually 1. So now, using this concept also, we can use that to solve our question in modulo. So now, in our table, the addition table, we can go ahead to find the expression for the modulo when we are doing our addition. In the first table, 2 plus 2 is 4. That's not up to 5. We don't have a problem with that. 2 plus 3 is 5, but we round that up to 0. 2 plus 4 is 6, and 6 will constitute mode. It will constitute 1 under mode 5. 2 and 3 again is 0. 3 and 3 is 6, which is 1. 3 and 4 is 7, and that will be 2 under mode 5. 2 and 4 is 6, that will be 1. 3 and 4 is 7, that will be 2. 4 and 4 is 8, that will be 3 under modulo 5. Now, that is quite easy, but now what about our multiplication table? Using the same concept, we can go ahead to find the values of our operation when we are using multiplication under modulo 5. Here, 2 times 2 is 4. 2 times 3 is 6. But now, if you want to write that out, you can say it's something like 2 times 3, that is 6. 6 divided by 5, we know it is 1, remainder 1. So, the remainder is what we write, that's 1. 2 times 4 is 8. 8 divided by 5 is 1. We have a remainder of 3, so we have 3. Then 2 times 3 again, we've expressed that before. We have it will be 1 under modulo 5. 3 times 3 is 9. And if we divide 9 by 5, we have 1 remainder 4. So we have 4. 3 times 4 is 12. We've done that before. That will be 2. Then 4 times 2, again, that's 8. We've done that before. 3 is 12. We've done that before also. And 4 times 4 is 16. We know that is also 1 because we've done that before. So with this, we've gotten all the entries in our table. We fill them up, and we are done with question number 11A, the first part. Now, to use the tables to solve the equation 4 with the operation on E and the operation on 2 is equal to 1 under modulo 5. Now, first and foremost, our 4 multiplied by E, we can take as a particular number, say x, so that you can write it out to be 4 times E plus 2 is equal to 1. Now, under modulo 5, let's say we are working backward. We need to ask ourselves, what number are we going to add to 2 to give us 1 under modulo 5? Looking at our addition table, we can see that 4 is the number that we can add to 2. So if you add 4 to 2, if you say 2 and 4, that will give us 1. So that means x that we are trying to find here, the number that we are trying to operate on 2 to give us 1 under modulo 5, that means x is 4. So we have 4 plus 2 is 1. And that means that 4 multiplied by E is the 4 that we just got initially. You know, we represented that as x. So now, we are querying a number that we can multiply by 4 to give us 4. And here, in our table, we don't really have that. We only have 2 multiplied by 2. We don't have, that's the only one giving us 4. There is no other entry. But now, if we're actually looking at this, and we really understand the concept under modulo 5, we are saying that we are looking for a particular number that will multiply by 4 under modulo 5 that will give us 4. That means that number will be a product of 4, and then if 5 is used to divide that number, we are going to get 1. So we are looking for a product of 4 that we have a remainder 4 whenever we divide that number by 5. So the product of 4 with remainder 4 whenever we divide by 5, actually it's as simple as 1. It is 1. Because normally 4 times 1 will actually give us 4, and 4 over 5 that we have will be like a remainder of 4 whenever we are working with that. So our E here is meaning that we have 4 multiplied by 1 is equal to 4 in modulo 5. So E in our first question is 1, and that is the answer to that question number A. Now question number B. Since we now understand the concept of using operation in modulo, now in question number B, we are given that 4 plus n times 2 is 2 in mod 5. Now, in the same manner, let's say our first 2 entries, 4 and n, let's call it y. So y multiplied by 2 is 2. Looking at our table, what entry do we have that is multiplying 2 to give 2? The other entry is 2. The only number that will multiply 2 and still give us 2 is actually 1. So, therefore, 4 plus n is equal to 1. That is the y that we are putting in, and that is under modulo 5. So, now, what number do we add to 4 that will give us 1 under the modulo operation 5? Now, we are looking at 4, then our answer should be 1. If you are to take out our previous addition, you can see that 4 and 2, whenever we add them together, it will give us 1 in modulo 5. So, meaning that our n n is equal to 2. And with that, we've also gotten the value of n. Now, in question number B, we are to consider this statement. We are told that P means that Landy has cholera and Q means that Landy is in the hospital. So if P results in Q, we are to state whether or not the following statements are valid. This is a logical question, and we need to actually raise an argument with ourselves. I love the fact that this type of questions are being featured in mathematics. Now, in the first case, we are being told that if Landy is in the hospital, then he has cholera. The interpretation of this, so normally we are given that P will tend to result in Q. The logical interpretation of this will mean that P is that if Landy has cholera, then definitely he's going to be in the hospital. That is a valid statement since P will lead to Q. So if he has cholera, then he will be hospitalized. Now, with that, we can go ahead to solve for our question. In the first case, they say that if Landy is in the hospital, then he has cholera. Now, in this question, they are reverting. They are saying that Q will lead to P. But is Q going to lead to Q? No, that's not valid. Landy may be in the hospital, but that does not necessarily mean that he has cholera. He may be in the hospital, maybe for some other sickness, maybe he has malaria, maybe he has some headache, maybe he sprained his ankle, but not because he has cholera. So the fact that he's in the hospital does not mean that he has cholera. So Q does not lead to P. He may be hospitalized for some other reason. So now, question number 2, if Landy is not in the hospital, then he does not have cholera. Okay, meaning that he is not Q going to the next situation that is not P. Well, this is quite valid. Why? Because if he's not in the hospital, then he does not have cholera. There are many things that can take him to the hospital, but the fact that he's not in the hospital means that he does not have cholera. So that is quite correct. Then if he does not have cholera, then he's not in the hospital. Well, this is quite interesting. He doesn't have cholera, then he's not in the hospital. That's not valid, because even though he doesn't have cholera, he may still be in the hospital for some other reasons, just like the argument in the first case. We had this question on bearing. We are told that a man starts from a point X and walks 285 meters to Y on a bearing of 078 degrees. He then walks due side to a point Z, which is 307 meters from X. We are to illustrate this information on a diagram. So, if we start from our point X and we draw our cardinal coordinates, then an estimate of 078 degrees from the north, because that's where our bearing starts from. On the north, we measure 078. Then the man moves to Y on that bearing on a distance of 285 meters. So it gets to Y. So if we also draw our cardinal point on Y, it's moving south down to point Z. So this is point Z. This point Z. And we're told that Z is 307 meters away from X. 307 meters away from X. So if you link back to X, that distance is 307 meters. So that's our diagram. Then we have to find the bearing of X from Z. So going to Z, we have to draw a cardinal point and find that bearing also coming from the north. On Z, we want to start from the north and measure the bearing to X. So we have to find that bearing, and then we also to find the distance between Y and Z. We can call that X, small letter S, since it's facing capital letter X. So now, this is interpretation of our question. we can go ahead and see what means we are trying to use to solve them. In question number B1, to find the bearing of x from z and distance between y and z. Now, for the first one, the bearing of x from z, as shown in red, if you look at the diagram and at point x and point y, we can notice an alternate angle that at point y, this angle is also going to be 78 degrees. And the reason is that it is alternate to the angle that is coming from x from the northern side. So angle XYZ is 78 degrees. It is alternate, is an angle that is alternate to the bearing of y from x. So we got that as 78 degrees. So we can notice a triangle here in which we can make use of the properties of a triangle in trying to solve them. And here we are looking for the angle being shown in blue at point Z. Let's call that theta. So we are looking for angle theta. But we know the side that theta is facing. Then we know another angle and the side that that other angle is facing. This is a perfect fit for the sine rule. So you can say sine theta over the side it's facing, which is 285, is equal to sine 78 over the side that 78 is facing, which is 307 meters. So by cross multiplying, our sine theta will be 285 sine 78 divided by 307. So if you use our calculator, 285 sine 78 divided by 307, 0.90805. Okay, so our theta is arc sine 0.9081. So arc sine, our answer, that's 65.24 degrees. 65.24 degrees. So meaning that that angle theta that is included in the triangle is 65.24 degrees. But nobody asked us to find angle theta. We are only asked to find the bearing of x from z. And that bearing was shown in red with that question mark. So if you look at that point, we have angle at a point, and the angle at a point is 360. So the bearing will be 360 minus 65.24. That is because the sum of angles at a point is 360 degrees. So with this, our bearing will be 360 minus 294.76. 294.76. But now we're asked to find it correct to the nearest known number. And even if we are not asked to find it correct to the nearest whole number, normally bearings are given in 3 digits. We don't include decimal places in bearing. So we also need to know that in our further questions, bearing is always in 3 digits. So this bearing, the bearing of x from z, approximately will be 295 degrees. And that is our solution. So now, you can say we want to go ahead to find the distance between y and z, but we know this is angle 78 degrees and this is angle 65.24 degrees. So now we're asked to find distance between y and z, which we tag as x initially. Now again, we can also decide to say we want to evaluate the angle at x in the included triangle. This angle that is being shown in blue, let's call it alpha. We've used theta before, so let's call this alpha. Now, by the principle of the sum of angles of a triangle, if we add the 3 included angles of the triangle, the sum is going to give us 180 degrees, because the sum of angles in a triangle is 180 degrees. So 78 plus 65.24 plus alpha is 180 degrees. So we can evaluate the value of alpha. So this will mean that alpha will be 180 minus 78 plus 65.24. So we can get our alpha if we bring in our calculator. 180 minus 78 plus 65.24. That's 36.76 degrees. That's alpha. Now, knowing the value of alpha, we can go ahead and say that we want to use either the sine rule or the cosine rule, because both can actually simplify the question that we are trying to solve in solving for x. But because we've used the sine rule before, in this case, I would prefer to use the cosine rule. Anyone you choose, you can actually use. By the cosine rule, the value of x here, x squared will be 285 squared plus 307 squared minus 2 multiplied by 285 multiplied by 307 cos alpha, and our alpha is 36.76. For understanding of this, you can check our videos on triangles so that you can have a good grasp of the sine rule, the cosine rule, and all the other properties of triangles. So using our calculator to evaluate this, just inputting all this value times 372 cos 36.76, that will be 35280. So 35 x will now be the square root of 35,280.87. So let's find that square root. The square root of our answer at 187.832. But now we are told that we have to find it correct to the nearest whole number. Our answer should be correct to the nearest whole number. So that will be approximately equal to 188 meters. And that is our answer. We had this question on the rotation of shapes, and we have been given the scale to use on both axes, 2 centimeters to 2 units on our graph paper, and we are to rotate in anti-clockwise rotation of 90 degrees about the origin. Now, first and foremost, before we launch into this, how do we go about solving this type of question? If we are to use the Cartesian coordinate as a guideline to see how a rotation of 90 degrees anti-clockwise will look like, let's take our Cartesian coordinates with labels y, x, minus x, and minus y. Now, if we rotate it in an anti-clockwise rotation of 90 degrees, now this will amount to having something like this. If you rotate this, x will come up, the y will go to our left, minus x will come down, and minus y will go to the right. Now, that is the effect of our rotation. Now, what's to note in this type of rotation is that from what we just explained, x becomes y if you look at all the case scenarios, and then y becomes minus x. So if we use this as a rule of thumb, we can actually go about plotting all the points that were given in the question and rotating them appropriately. So for the case P that is defined by 3, 2, we are saying that x will become y, so P1 will become x will become y, so x, which is 3, will become y, so we have P1 will be minus 2, 3, because x is now y and y is now minus x. So for our q minus 1, 5, q1 under the anticlockwise rotation of 90 will become minus 5 comma minus 1, because x becomes y and y becomes minus x. Then r of 0 comma 8 will become r1. We have 0 and minus 8 comma 0. Then for our s, which is given as 3 comma 7, we are going to be having minus 7 comma 3. So with this, these are the new values that we amount to anticlockwise rotation of 90 degrees about the origin. Then in the second one, we are going to find P2, Q2, R2, S2 in the reflection of the line y minus x is equal to 0. If we take y minus x is 0, that means that y is equal to x if we take x to the right hand side. So interestingly, this is just like swapping both sides. So from our P1 to P2, what we need to do is to swap the coordinate of x and y. So instead of minus 2, 3, we have 3 minus 2. For Q2, we have minus 1 minus 5. For R1, we have R2 will be 0 comma minus 8. And S1 to S2 will be 3 comma minus 7. So these are the values that we need to plug into our graph to draw our quadrilateral and resolve the question that we're asked in this particular question. So with this, we can go ahead, then after that, describe the transformation and then what type of quadrilateral it is cutting. No problem with that. Let's take our graph paper, and then with the scale that we have been given, 2 centimeters to represent 2 units on both x and y axis, we can plot our x and y axis. We have our x axis, then we want to also get our y axis. So this is our x and our y axis, y and x minus, don't need to put all those. So we have the origin, and 2 centimeters to represent 2 units will give us the calibration as is being shown. So once we are through with the calibration, we can now go ahead and start with all our points showing their vertices and their coordinates as requested. Now in the first case, we want to show point P having its coordinate as 3, 2. So P with 3, 2. And now 3 on the x-axis will be between 2 and 4, and here we have 2. If we trace the two to one another, the point of intersection will determine point P. So this is the same rule of thumb that we are going to be applying for each of the points that we want to note, but I won't be noticing them from the x and y axis again. I will just plug in the value. So that's P. Q will now be minus 1 and 5. Okay, so the point of intersection is here. So we have, this will be Q, which is minus 1, 5. Then our R, I want to take R 0 and 8. X is 0, Y is 8. That's very straight and direct. R 0, 8. Then S 3, 7. S will be 3 is here, and then 7 on the y axis, 7 between 6 and 8. All right. So we have S3, 7. So with this, if we join all the points together, we are going to have our quadrilateral. This quadrilateral PQRS, and this is our quadrilateral as requested. So with that, we've been able to find the quadrilateral defined by PQRS, but then we can also go to P1, Q1, R1, and S1. So I want to use my red ink now. P1 is minus 2, 3. So minus 2 on the x-axis, 3 on the y-axis. So here, minus 2 and 3. So this is the point of intersection. I can trace. But since I know it, I will just plug it in. Minus 2, 3. This is P1 as is defined by minus 2, 3. Then Q1 is minus 5, minus 1. And there I have the point of intersection. So minus 5, minus 1. Q1 minus 1, minus 5, minus 1. Then R1 minus 8, 0. Minus 8, 0. And then finally S1 minus 7, 3. X is minus 7, Y is 3. This is X1 minus 7, 3. So I can also draw my quadrilateral that is defined by P1, Q1, R1, and S1. All right. So with that, I've also defined the quadrilateral P1, Q1, R1, and S1. Then, continue with the problem. We are asked to define y minus x is 0, and we have gotten those values as P2, Q2, R2, and S2. So for P2 is 3, minus 2. So 3, minus 2. Q2 is minus 1, minus 5. So x is minus 1, y is minus 5. So this is here as Q2. 1, minus 5. Then R2 is 0, minus 8. R2, 0, minus 8. And then S2 is R, minus 7. S2 is 3, minus 7. 3, minus 7. And I can also join all the points. All right. Wow. And with this, I've been able to plot the shape, the quadrilateral that was requested of us to draw from our diagram. This, the S1, P1, R1, Q1 is a rotation by 90 degrees anticlockwise. And then the P2, S2, R2, Q2 is when we have y minus x is equal to 0. So now we are asked that what transformation is happening between PQRS to P2, Q2, RS, S2. See if between the one shown in blue and the one shown in purple. Now, if you look at this critically, and if you consider the x-axis, now it's looking as if there's a mirror image of the quadrilateral PQRS that is being imaged at P2, Q2, R2, S2. So it's looking as if X, the x-axis, is looking like a mirror. So that means that this transformation that we are being requested to define, the transformation is a reflection around the x-axis. It's a reflection about the x-axis. So it's as if we are reflecting the image of P, Q, R, and S by the x-axis to get P2, Q2, R2, and S2. Now, that's one definition. Or this is also looking like a 180 degree either clockwise or anti-clockwise rotation of PQRS. So either of the two is actually giving us P2, Q2, R2, and S2. So, and finally now our last question, we are told that there is a point. Let's check the question. They said that P1, Q1 of the quadrilateral, P1, Q1, R1, S1 cuts the x-axis at point W. So what type of quadrilateral is P1, S1, R1, and W? So now this is W cutting P1 and Q1 on the x-axis. So the shape being drawn in green is the quadrilateral that we are asked to define, that what type of quadrilateral is it. So if I'm to draw that out, yes, that's the green shape. That's that green shape. And the appropriate label is something like is S1 here, P1 here, now W here, and then R1. Now, what shape is this? This is nothing but a trapezium. This is a trapezium. And with that, our question on the rotation of shape has also been answered. That is the detailed solution to all the questions from the November-December 2018 Mathematics WAEC Paper 2, and it has been a long journey. I hope you really enjoy it. Now, we are doing this because we are aiming for academic excellence for you, and as an appreciation of the effort that is put into this video, subscribe to the channel and click on the notification bell so that you can have access to all of our videos that we upload. And we are wishing you the very best of luck in your exams: IGCSE, WAEC, NECO, GCSE, GED, and even for your JAMB. It's Davetuts Academy. Until next time, God bless you.